Hi, in this video, we're going to talk about the problems with the Python 2.2 MRO algorithm and why we have a new MRO algorithm called C3 linearization for the later versions of Python. So let's start with a little exercise on this slight variation of an inheritance hierarchy that we looked at earlier. So in this hierarchy, the class C also has a parent that is D. And so please pause the video and try to work out the MRO according to the 2.2 algorithm. And after you work it out by hand, you can type this out and try to see what is the MRO that Python tells you. All right, so if you work it out by hand, so we're going to start at A, right? We go up and go to the left branch first, so A, B, and D. And now we backtrack from D, and there is a branch to the right, so we go to E, and then we backtrack and come back down here until we get to A, which then there is another branch going up to C. Now, what gets interesting is now C has a parent that is D, so we have to follow this connection here to go to the left first. So from C, we're going to go to D, and then we backtrack and go to the other parent of C, which is F. And then finally we get to O. Now, then we look at here and let's remove the duplicate. The duplicate is there is a D, so we get rid of D and we end up with the MRO, at least according to the 2.2 algorithm of A, B, E, C, D, F, and O at the end always. Now, if you look at the MRO a little closer, you see that it goes from A to B, and then E, and then C, and D, and F. So it's really kind of all over the place. It doesn't seem right. Now, if we look at what Python tells us, then I already typed it out here. So if we run it, we get the MRO for A as A, B, C, D, E, F. So if you look at what it is in the picture, A, B, C, D, E, F, that feels more correct because, well, it goes from bottom to top and goes from left to right. Now, that is definitely different from the MRO according to the 2.2 algorithm. So if we really look at what's wrong with the MRO derived from the 2.2 algorithm, the biggest problem really is E comes before both C and D. But if you look at E, well, compared to D, E is to the right of D, whereas normally MRO, we like to go from left to right, right? So that's the problem between E and D. Now, between C and E, well, C is closer to A than E is. So normally we want to search C first before we go to E. But here is not the case, right? We search E before C. So that's another thing that is wrong with this MRO. Now, this is intuitively what is wrong with this MRO. Now, what more formally, the problem is that, let's say we have a smaller hierarchy that consists of only B, D, and E. Well, then in that case, the MRO for B is B, D, and E, right? However, the bigger hierarchy that consists of the smaller one that has only B, D, and E, the MRO for A, as we just worked out, actually violate the MRO of the smaller hierarchy, because in the MRO of the bigger hierarchy, the order is B, E, and D, and it's no longer B, D and E. So it is problem like this that motivates for a newer MRO algorithm for Python 2.3 and the later version including Python 3. So this new algorithm has a fancy name called C3 linearization, and this algorithm is academically vetted, meaning it's been vigorously proved and peer reviewed and all that. So it works kind of consistently, perfectly. And the way it works is kind of from a 50,000 feet level, is that it really kind of addressed the problem that we discussed here. So it works by start building smaller MRO first, and then it builds bigger ones. But every step of the way, it makes sure that the bigger MRO respect the precedence set by the smaller MROs. So it keeps building these bigger and bigger MRO until it builds the entire MRO for the whole hierarchy, or that it fails to build a bigger MRO that is consistent with the precedence set by all the previous smaller MROs. In that case, it will declare that you have a horrible, no good inheritance hierarchy. Now, it is quite long and detailed, so we simply do not have the time to cover it in this class. But if you're interested in it, there are plenty of online resources that you can find that covers this topic, including the Wikipedia article that is linked from this slide. I do want to give a quick example of what an inconsistent inheritance hierarchy is. So here is one that we have a class B that inherits from A, as well as a class C that inherits from both A and B. So why is this inheritance hierarchy inconsistent? So the problem is that when B inherits from A, well, the MRO says to search B before A, right? However, when C inherits from both A and B, but it inherits A first, then given the rule of going from left to right, then it says A must be searched before B. So the MRO for C is CAB. So we have one relationship that says B and then A, the other says A to B. So it's impossible to satisfy both of these. Right? So if we type this out and we actually run this thing, it actually says that cannot create a consistent MRO for A and B. So given the fancy new algorithm that replaced the old 2.2 MRO algorithm, why did we spend so much time studying it? Well, I think there are a lot of value in that algorithm. So first, it is simple to understand. And second, it is actually correct and applicable in many of the real world inheritance hierarchy that are well designed and not overly convoluted or complicated. So, and finally, its general idea of going from bottom to top, doing a depth first search, and then going from left right search is really applicable even in the C3 linearization algorithm, even though as we saw, the 2.2 algorithm does fail in some of the trickier situations. So as with a lot of things in life, we just have to know their limitations and what they can and cannot do. And finally, if you're interested in the history of Python's MRO, there is a blog post by the guy who did it. I really cannot say his name, but he's the inventor of Python, and here is the link to that article.